Hello and welcome to our final lesson in Unit 8, the Inequalities unit. So today we're still solving quadratic inequalities. 2 lessons ago we learned how to solve them in 2 variables, and that method involved graphing them and then shading above or below with a broken or solid parabola. When we solve in 1 variable, there's no graphing, so it's still quadratic inequalities, but instead of graphing, we're in 1 variable and we're going to solve using sign diagrams. So that's why we had that lesson yesterday on sign diagrams. And again, sign diagrams, if you go into calculus, it's such a strong foundation. The calculus class right now that I'm teaching, every single day they use sign diagrams as part of their answer. So every single question, step 1 is do a sign diagram. Actually, some questions involve multiple sign diagrams within the same question. So the best thing to prepare for calculus is to learn how to do sign diagrams in grade 11. So like I said, we're always looking way into the future for you. So we're not teaching you skills just to get through this next month. I'm looking ahead to the next few years to set you up for success in your math career. Okay, so how do we solve quadratic inequalities in 1 variable? Well, there's 4 steps. Step number 1 is to factor, and then from the factored form, make the sign diagram, which is we learned how to do last lesson. And then basically from the sign diagram, you just read the information, and I'll show you how to do that right away. Then your final answer, we just express it using set or interval notation. I will use interval notation, but like I said, you can do set. We learned that back in grade 10 math, and this doesn't go away either. So especially grade 12 pre-cal, lots of graphing and then lots of analysis using set and interval notation. But like I said, for this one, there's no graphing. It's a sign diagram, and read the answer from the sign diagram. So here we go, we'll just do 2 examples together. So x squared minus 10x plus 9 equals 0. You can tell that there's no y value, right? This was set to y, we'd actually have to graph it on graph paper, shade above or below. But it's not 2 variables, it's 1. There's no y value, it's just an x value. So we can't graph using that one, so instead we factor. So the factored form is x minus 9, x minus 1. That's as low as we can go. So now we go to our sign diagram, which we learned how to do last class. We have 2 key points. Our key points are plus 9 and 1. Now, we don't have to draw it to scale, but we just have to put the numbers in the right order. So 1 comes before 9. Then we take a large key point. Any key point larger than our largest key point works. So anything 10 or greater works. Well, 9.1, anything greater than 9 works. But we usually use a million because it makes it a little bit more fun to run through a million. So again, we don't care what the value is, we want the sign. A million minus 9, I don't care what the number is, but that would be a positive value. A million minus 1, I don't care what the number is, that would be a positive value. A positive times a positive gives you a positive. So if I run any number larger than 9, this inequality will give me a positive number. Again, I don't care what that actual value is because it's a sign diagram. We just want the sign. Any value in this region would make this value positive. Then, that's the only one I have to test. I use the rules we learned last year, so you go right to left. The first key point I hit is 9. 9 comes from here. Now, it's not whether 9 is odd or even, it's whether the exponent outside of the bracket is odd or even. This is all to the power of 1. 1 is odd, so if it's odd, the rule is you change the sign. Then we keep going to the left. The next key point we hit is 1. This is where the 1 came from. Now, it's not whether 1 is odd or even, it's the exponent outside of the bracket is odd or even. So that's 1 again, which is odd, so it switches back. So that's our sign diagram, but we're not done. Sometimes students do the sign diagram and then they stop. Well, you haven't actually answered the question, so you're gonna lose quite a bit of marks if you don't complete the question. Now, you don't have to shade. I do, because I find it easier for me to see the answer. Technically, you can find your answer from here, but let's read the inequality. We want to know where this inequality is less than or equal to 0. So I'm looking for negative regions. You don't have to do that, just something I do to visualize. So that means any number I pick in this region will make that inequality negative. That's what the sign diagram tells me. So any number between 1 and 9 will apply. Now, do I use square brackets or round? This is where you look. It's less than or equal to, so we include our endpoints. So the solution is 1, 9 with square brackets. That's it. No graphing. You just factor, make your sign diagram, read your information off of there. So it should be nice and easy compared to our graphing. Okay, one last example. X squared minus 5x is greater than 0. Again, there's no y value, so this is 1 variable, not 2, so I don't actually graph. I just factor and make my sign diagram. Okay, and then using this, I have 2 key points, 0 and 5. This is a common mistake, and that was actually happening in our non-permissible units. When you have an x by itself, that gives you a key point of 0. That's an easy one to miss. Again, we go to our sign diagram. 0 comes before 5, so those are my 2 key points. Then I run a number through, any number larger than my largest key point. So any number greater than 5. I use a million because that's fun to say. A million by itself is positive. A million minus 5 is still positive. Positive times a positive gives me positive. I don't care what the actual number is. Sign diagrams just want to know, does it give a positive or negative value? So any number larger than 5 would make that inequality positive. Then I move right to left. The first key point I hit is 5. 5 comes from here. Again, it's not whether 5 is odd or even, it's the exponent. Oops, I don't think I wrote my bracket there. I have a communication error. Okay, I'll fix that up. So, bracket greater. So it's not whether 5 is odd or even, it's the exponent. That's all to the power of 1. That is odd, so you switch the sign. Then the next key point I hit is 0. That comes from here. X, it's by itself. That's technically to the power of 1, so it switches again. Now you'll notice for most of them, they're plus, minus, plus. So sometimes I've heard students say, why did we have that whole lesson on sign diagrams? Is it always going to be plus, minus, plus? Well, for grade 11 pre-cal, yes. But when you hit calculus, no, it's not. So I gave you the full story last time. So yes, most of our cases will come through. They'll either be plus, minus, plus, or minus, plus, plus, or sorry, the opposite. But you still need to learn the key concepts because definitely when you hit calculus, you're going to see a whole bunch of different situations. So even doing this lesson now, there'll be something in your brain that will stick for future, so it won't be completely brand new when you do calculus. Okay, now which regions do I want? I want where this is greater than 0, so I'm looking for the positive regions. Again, you don't have to shade. It's not like you're shading in the other diagram where you have to. I personally do that just so I can visualize what's going on here. So basically, any number in this region or this region would make that inequality positive. So how do I list it? I have 2 regions. So any number from minus infinity to 0. Oh, now what kind of bracket am I using? Round or square? Let's look at the question. It's just greater than, not greater than or included, so that's why it's round. But there's another region, or, remember we did learn that previously, any number in this region or any number in this region would make that statement correct. So that's our full solution. So any number from minus infinity or from 5 to infinity would make that inequality positive. Okay, there you go, our final lesson. So good luck with this. And then once we're done with this, we have one last unit to do and then we are done. So good luck, hang in there.